the night that changed everything. Close your eyes for a moment and imagine this. It's a warm summer evening in 1609. The sun has just dipped below the horizon in the small Italian town of Padua, Italy, painting the sky in soft purples and golds. A gentle breeze carries the scent of jasmine through narrow cobblestone streets where candlelight flickers behind shuttered windows. In a modest study filled with books and strange instruments, a man named Galileo Galilei holds something extraordinary in his weathered hands. It's a simple tube no longer than your arm, with pieces of curved glass at each end. But this humble device is about to reveal secrets that have been hidden since the dawn of time. As Galileo steps out into his garden and points this telescope toward the heavens, he has no idea that he's about to become the first human being to truly see our cosmic home, the magnificent, mysterious river of light we call the Milky Way. Tonight, my friend, we're going to follow in Galileo's footsteps. We're going to journey together through 4 centuries of discovery, wonder, and revelation as humanity slowly unveiled the secrets of our galactic home. Along the way, we'll uncover 100 remarkable facts about the Milky Way, each one a stepping stone in our eternal quest to understand our place in the vast, beautiful cosmos. So settle back, let your breathing slow, and prepare to drift through time and space on a gentle tide of starlight and story. The first glimpse of forever. The ancient observers and early mysteries. Long before Galileo ever dreamed of his telescope, humans gazed up at the night sky and wondered about that ghostly band of light stretching from horizon to horizon. Let's begin our journey with our very first fact. Fact number 1. The name Milky Way comes from the ancient Greek Galaxias Kyklos, meaning milky circle. But this wasn't the only name our ancestors gave to this celestial river. The ancient Romans called it Via Lactea, the Milky Road. In Chinese mythology, it was known as the Silver River, while Native American tribes saw it as the Trail of Spirits, a pathway walked by souls journeying to the afterlife. Picture, if you will, a young shepherd in ancient Greece, lying on his back in a meadow dotted with sleeping sheep. The air is cool and sweet with the scent of wild thyme. Above him, unpolluted by any earthly light, the Milky Way stretches like a luminous river across the star-drunk sky. He doesn't know what it is, this bridge of light, but something deep in his soul recognizes it as sacred, as meaningful, as home. Fact number 2. The ancient Greek philosopher Democritus, around 460 BCE, was one of the first to suggest that the Milky Way might be composed of distant stars. This was a breathtaking leap of imagination for its time. The idea that those tiny points of light might be suns like our own, but so impossibly far away they blurred together into a river of luminescence. But it would be over 2,000 years before anyone could prove Democritus right. Fact number 3. Aristotle, that towering intellect of the ancient world, disagreed with Democritus. He believed the Milky Way was an atmospheric phenomenon, perhaps a kind of cosmic weather, burning vapors in the upper air. For nearly 2 millennia, Aristotle's view held sway, and humanity continued to gaze up at their galactic home without truly seeing it. Imagine the weight of that unknowing, generation after generation of humans living inside something so vast and magnificent, yet unable to comprehend what surrounded them. It's like being a single cell in a great organism, aware of some larger presence, but unable to grasp its true nature. Fact number 4. Persian astronomer al-Biruni in the 11th century observed that the Milky Way appeared nebulous to the naked eye, but might resolve into individual stars with better observation. He was like a person squinting at a distant forest, sensing the individual trees, but not quite able to make them out clearly. The medieval Islamic astronomers were remarkable in their precision and patience. Picture al-Biruni on a clear night in Baghdad, his astrolabe in hand, carefully mapping the heavens with devotion that bordered on worship. He knew he was looking at something profound, even if he couldn't quite grasp what it was. Fact number 5. Medieval European scholars, influenced by Aristotle's teachings, often described the Milky Way in their manuscripts as the circle of light or heaven's belt. Illuminated manuscripts from this period show it as a golden band adorned with stars, more artwork than science, but beautiful in its own way. In the scriptoriums of medieval monasteries, monks would labor by candlelight, copying and illustrating these cosmic mysteries. Their quills would scratch across parchment as they tried to capture in gold leaf and azure ink something that was fundamentally beyond human understanding. Yet in their artistic interpretations, there was a recognition of beauty, of divine mystery, that perhaps brought them closer to truth than they knew. Fact number 6. The invention of the telescope in the early 1600s marked the beginning of the end for humanity's cosmic ignorance. But even before Galileo turned his telescope skyward, the instrument itself had a humble beginning, created by Dutch lens makers who were simply trying to make distant ships appear closer. Think about that beautiful irony. An instrument designed to see across earthly oceans would soon reveal the vast oceans of space. Hans Lippershey, the Dutch spectacle maker often credited with the telescope's invention, had no idea he was creating the key that would unlock the cosmos. Fact number 7. When Galileo first turned his telescope toward the Milky Way in 1609, what he saw shook him to his core. The ghostly band of light resolved into countless individual stars, so many that he couldn't begin to count them. In that moment, Democritus was vindicated across the centuries, and humanity's understanding of its place in the universe changed forever. Picture Galileo in that garden in Padua, his eye pressed to the telescope, his breath catching as the impossible became visible. Imagine his wonder, his excitement, perhaps his fear as he realized that the universe was far, far larger and more complex than anyone had ever dreamed. He was seeing for the first time in human history that we live not just under the stars, but among them. Fact number 8. Galileo's telescope could only magnify objects about 20 times, yet this was enough to reveal what he called a congeries of innumerable stars. He wrote in his Sidereus Nuncius, Starry Messenger, that the Milky Way was nothing but a congeries of innumerable stars distributed in clusters. The language he chose is telling, congeries, meaning a collection or assemblage. He was groping for words to describe something that had no precedent in human experience. How do you describe the undescribable? How do you count the uncountable? Fact number 9. Other early astronomers quickly confirmed Galileo's observations. Simon Marius in Germany and Thomas Harriot in England independently observed the stellar nature of the Milky Way. It was as if a veil had been lifted from humanity's eyes, and suddenly everyone could see what had been hidden in plain sight for millennia. This was the beginning of a great awakening, the realization that we live in a universe of almost incomprehensible size and complexity. But it was only the beginning. The true scope of our galactic home would take centuries more to reveal itself. By the mid-1600s, astronomers began to notice that the Milky Way wasn't uniform. It had bright patches and dark lanes, thick regions and thin areas. They were seeing the structure of our galaxy without yet understanding what they were looking at. Imagine trying to understand the architecture of a vast cathedral while standing inside one of its stones. That's what these early astronomers were attempting to do, to comprehend the structure of something so large that they existed as mere specks within it.
The map makers of eternity. Measuring the immeasurable. As the 18th century dawned, humanity had established that the Milky Way was made of stars, countless distant suns scattered across the heavens. But new questions arose. How many stars? How far away? And most puzzling of all, what shape was this cosmic congregation? Fact number 11. William Herschel, the German-British astronomer, began the first systematic attempt to map the Milky Way in the 1780s. Using telescopes he built himself, some of them the largest in the world at the time, he embarked on what he called star gauges, counting stars in different directions to determine the shape of our stellar system. Picture Herschel on a cold winter night in Bath, England. His sister Carolyn by his side, both of them bundled in heavy coats as they peer through their massive telescope. Their breath forms clouds in the frigid air, but they persist night after night, counting stars with the patience of cosmic accountants. Herschel was attempting something that had never been done before, to create a map of infinity. Fact number 12. Herschel's star counts led him to conclude that the Milky Way was shaped like a disk, with our solar system near the center. He estimated it to be about 5 times longer than it was wide. While his method was ingenious, he couldn't account for interstellar dust that obscured distant stars, leading to an underestimate of the galaxy's true size. Think about the audacity of this endeavor. A single human standing on a small planet, trying to measure the dimensions of something so vast that light itself takes over 100,000 years to cross it. It's like an ant trying to map the continent it lives on. Yet Herschel persisted, driven by an insatiable curiosity about the cosmos. Fact number 13. The first hint that our galaxy might be larger than Herschel imagined came from the study of nebulae, those fuzzy patches of light scattered across the sky. Some astronomers suggested these might be island universes, other Milky Ways existing far beyond our own. This idea, first proposed by philosophers like Immanuel Kant, was so radical it seemed almost heretical. The notion that our Milky Way might be just one of countless others scattered throughout an even vaster space challenged every conception humans had about their cosmic significance. Fact number 14. In the early 1900s, astronomer Jacobus Kapteyn used more sophisticated statistical methods to map the galaxy. His Kapteyn universe was still relatively small and placed our solar system near the center, but it was the most accurate picture of the Milky Way's structure up to that time. He worked with the dedication of a monk copying scriptures, analyzing photographic plates taken at observatories around the world. Each plate was like a window into deep space, revealing thousands of stars whose light had traveled for decades or centuries to reach Earth. He was quite literally studying ancient light, archaeological evidence of the cosmos. Fact number 15. The breakthrough came with Harlow Shapley's study of globular clusters in the 1910s. These spherical collections of ancient stars scattered around the galaxy like celestial pearls held the key to understanding our true position in the Milky Way. Shapley discovered that globular clusters were not evenly distributed around the sky. They were concentrated in the direction of the constellation Sagittarius. This, he realized, meant that the center of our galaxy lay not where we are, but in that direction. We were not at the center of our cosmic home. We were out in the suburbs. Fact number 16. Using Cepheid variable stars as cosmic distance markers, Shapley determined that the Milky Way was much larger than previously thought, about 300,000 light-years across. While this was still an overestimate, we now know it's about 100,000 light-years across. It was much closer to the truth than earlier calculations. The realization that we live in the cosmic equivalent of a small town rather than the capital city was another humbling moment in human history. First, we learned we weren't at the center of the solar system. Then we learned our solar system wasn't at the center of the galaxy. The universe, it seemed, had no special place for humanity, except in our own hearts and minds. Fact number 18. The nature of spiral nebulae remained controversial well into the 1920s. Were they part of our galaxy or separate galaxies entirely? The Great Debate between Harlow Shapley and Heber Curtis in 1920 epitomized this cosmic controversy. Picture the two astronomers on stage at the National Academy of Sciences in Washington, D.C., each presenting their vision of the universe's scale and structure. Shapley argued for a large Milky Way containing all the known nebulae. Curtis countered that spiral nebulae were separate island universes. They were debating nothing less than the fundamental nature of cosmic reality. The question was settled by Edwin Hubble in 1925. Using the new 100-inch telescope at Mount Wilson Observatory, he identified Cepheid variable stars in the Andromeda Nebula, proving that it lay far beyond the boundaries of our own galaxy. That night on Mount Wilson, as Hubble peered through the eyepiece and identified those telltale variable stars, he was witnessing the birth of modern cosmology. The universe had suddenly become vastly larger, filled with countless galaxies scattered through immeasurable space. Our Milky Way was just one among billions. Fact number 19. Modern measurements show that our galaxy contains between 200 and 400 billion stars. To put this in perspective, if you could count one star per second, it would take you over 12,000 years to count them all, and that's assuming you never stop to sleep, eat, or rest. Imagine trying to comprehend such a number. If each star were a grain of sand, you would need several large beaches to hold them all. Yet each of those grains of sand is actually a sun, potentially warming worlds we can't even imagine. The Milky Way is a barred spiral galaxy, meaning it has a central bar-shaped structure from which spiral arms extend. This wasn't discovered until the 1990s, when infrared observations could penetrate the dust that obscures our view of the galactic center. For decades, we lived inside our galaxy without knowing its true shape, like inhabitants of a house who had never seen it from the outside. The discovery of the central bar was like finally stepping back and seeing the architecture of our cosmic home for the first time. The architecture of wonder. Understanding our galactic home. Now that we've followed humanity's journey to understanding the basic structure of the Milky Way, let's explore the magnificent architecture of our galactic home. Each fact we'll discover is like examining a different room in a vast cosmic mansion, one so large that light itself becomes our measuring stick. Fact 21. The Milky Way's disk is remarkably thin relative to its width. If you scaled the galaxy down to the size of a dinner plate, the disk would be about as thick as a sheet of paper. We live in what astronomers poetically call a thin disk, a cosmic crepe spinning through space. Imagine our solar system as a single point somewhere in that paper-thin disk, about 2/3 of the way from the center to the edge. We're cosmic suburbanites, residents of the quiet neighborhood in the galactic outer reaches, far from the bustling downtown of the galactic center. Fact 22. Our galaxy rotates, but not like a solid wheel. Different parts rotate at different speeds, a phenomenon called differential rotation. Stars near the center complete an orbit much faster than those on the outer edges. Our solar system takes about 225 to 250 million years to complete one orbit around the galactic center. This means that since the Earth formed 4.6 billion years ago, our solar system has completed only about 18 to 20 trips around the galaxy. Dinosaurs lived during our most recent quarter orbit. The last time we were in our current position relative to the galaxy, mammals were just beginning to diversify after the extinction of the dinosaurs. Fact 23. The Milky Way has several distinct components: the thin disk, where most stars, including our sun, reside, a thicker disk of older stars, a central bulge, and a vast spherical halo containing globulent clusters and dark matter. Picture these components like layers of a complex pastry, each with its own character, age, and story to tell.
The thin disk is like the filling, rich with young blue stars and ongoing star formation. The thicker disk and bulge are like older, more established layers, while the halo is the encompassing wrapper that holds everything together. At the very heart of our galaxy lies a supermassive black hole called Sagittarius A star, pronounced A star. This cosmic monster contains the mass of about 4 million suns, all compressed into a space smaller than our solar system. For decades, this black hole was invisible to us, hidden behind vast clouds of interstellar dust. But we could see its effects: stars near the galactic center moving in tight, rapid orbits around something we couldn't see. It was like watching dancers whirl around an invisible partner, their movements revealing the presence of something massive and dark. Fact 25. The discovery of Sagittarius A star earned the 2020 Nobel Prize in Physics for Reinhard Genzel and Andrea Ghez, who spent decades tracking the orbits of stars around the galactic center. Some of these stars reach speeds of up to 3% the speed of light in their closest approaches to the black hole. Imagine the patience required for this discovery, watching stars for decades as they trace their elliptical paths around an invisible gravitational giant. Each observation was like a single frame in a cosmic movie that took decades to complete. Fact 26. The spiral arms of the Milky Way are not permanent structures, but rather density waves, regions where stars and gas temporarily bunch up as they orbit the galaxy. It's like a cosmic traffic jam that moves around the galaxy, creating the beautiful spiral pattern we would see if we could view our galaxy from outside. Think of it like ripples in a pond, but ripples made of stars and gas clouds. As material flows into these density waves, it gets compressed, triggering the birth of new stars. The spiral arms are thus stellar nurseries, cosmic maternity wards where new suns are born. Fact 27. Our galaxy has at least 4 major spiral arms: the Perseus arm, the Norma arm, the Scutum Centaurus arm, and the Sagittarius arm. We live in a smaller structure called the Orion arm or local arm, which lies between the Perseus and Sagittarius arms. Our location in this minor arm might seem unremarkable, but it's actually quite special. We're in a relatively quiet galactic neighborhood, away from the more chaotic regions of the major spiral arms where massive stars are born and die in spectacular explosions. Our galaxy is warped. It's not perfectly flat like a dinner plate, but rather twisted like a vinyl record left in the sun. This warping is likely caused by the gravitational influence of our satellite galaxies, the Large and Small Magellanic Clouds. This discovery was another humbling reminder that even our home galaxy is not the perfect symmetrical structure we once imagined. Like everything in the universe, it's dynamic, complex, and influenced by its cosmic neighbors. Interstellar dust plays a crucial role in our galaxy. This cosmic dust, made up of tiny particles of carbon and silicon and other elements, dims and reddens starlight, making distant stars appear fainter and more orange than they actually are. This dust is not waste or debris, it's the raw material for future worlds. Every atom of carbon in your body, every grain of silicon in the sand beneath your feet, was once part of this interstellar dust, forged in the heart of an ancient star and scattered into space when that star died. The galaxy is permeated by magnetic fields, vast, invisible highways that channel charged particles and influence the behavior of interstellar gas clouds. These magnetic fields are detected by observing how they align dust grains, which polarize starlight in specific ways. Imagine the galaxy as filled with invisible rivers of magnetism flowing and eddying through space. These magnetic currents help regulate star formation, channel cosmic rays, and create some of the most beautiful structures we see in deep space.
The stellar citizenry. The lives and deaths of galactic stars. Within our galactic home live hundreds of billions of stars, each one a sun, each with its own story of birth, life, and death. Let's explore the diverse stellar population of the Milky Way, from the most common red dwarfs to the most exotic stellar remnants. Fact number 31. The most common stars in our galaxy are red dwarfs, small, cool, long-lived stars that make up about 75% of all stars in the Milky Way. These cosmic misers burn their nuclear fuel so slowly that they can shine for trillions of years. Picture a red dwarf as the ultimate survivor, a star so efficient with its resources that it will outlive every other type of star. Long after our sun has died, long after the galaxy itself has changed beyond recognition, these small red stars will still be burning steadily, the final lights in an aging universe. Fact number 32. At the other extreme are the massive blue giants, stars that burn hot and bright but live fast and die young. A blue giant might contain 20, 30, or even 100 times the mass of our sun, but it will live for only a few million years before exploding as a supernova. These are the rock stars of the galaxy, brilliant, spectacular, and doomed to burn out in a blaze of glory. When they die, they seed the galaxy with heavy elements, creating the raw materials for planets and ultimately for life itself. Fact number 33. Our sun is a middle-aged, middle-class star, neither the smallest nor the largest, neither the hottest nor the coolest. It's what astronomers call a G-type main sequence star, and it's been shining steadily for about 4.6 billion years, with another 5 billion years of fuel remaining. In the grand census of galactic stars, our sun is remarkably average, which might be exactly why it's been able to nurture life for billions of years. Sometimes the ordinary is the most extraordinary of all. Fact number 34. Star formation in the Milky Way continues today, primarily in the spiral arms, where gas clouds collapse under their own gravity. We can observe stellar nurseries like the Eagle Nebula, where new stars are being born right now, their birth cries visible as glowing hydrogen gas. These stellar nurseries are among the most beautiful sights in the galaxy, vast caverns of gas and dust illuminated by the fierce light of newborn stars. They remind us that our galaxy is not a static structure, but a living, breathing entity, constantly renewing itself through the birth of new stars. Fact number 35. The galaxy recycles its material through stellar death and rebirth. When massive stars explode as supernovae, they scatter heavy elements into space. These elements, carbon, oxygen, silicon, iron, become incorporated into new generations of stars and planets. This cosmic recycling means that we are quite literally made of stardust. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of these elements were forged in the nuclear furnaces of ancient stars and scattered across the galaxy when those stars died. Fact number 36. Some stars in the Milky Way are almost as old as the universe. The oldest stars, found in globular clusters and the galactic halo, formed when the galaxy was young and the universe contained far fewer heavy elements than it does today. These ancient stars are living fossils, witnesses to the galaxy's youth. By studying their composition and properties, astronomers can piece together the early history of the Milky Way, how it formed, how it grew, how it became the magnificent spiral we inhabit. Fact number 37. Binary and multiple star systems are extremely common in our galaxy. More than half of all stars have at least one stellar companion, locked in orbital dances that can last for billions of years. Imagine two stars waltzing through space, their gravitational embrace keeping them bound together through eons of cosmic time. Sometimes these stellar partnerships are peaceful, but sometimes they're dramatic. One star can steal material from its companion, leading to nova explosions and other spectacular phenomena. Fact number 38. The galaxy contains exotic stellar remnants, white dwarfs, neutron stars, and black holes, the corpses of stars that once shone brilliantly.
A white dwarf is about the size of Earth but contains the mass of the Sun. A neutron star is even more extreme, the size of a city but containing 1.5 times the Sun's mass. These stellar remnants are laboratories for extreme physics, where matter behaves in ways impossible to replicate on Earth. A teaspoon of neutron star material would weigh about 1 billion tons, as much as a mountain compressed into the space of a sugar cube. Pulsars, rapidly spinning neutron stars, act like cosmic lighthouses, sweeping beams of radiation across space with clockwork precision. Some pulsars spin hundreds of times per second, more precise in their timing than the best atomic clocks. When astronomers first discovered pulsars in the 1960s, the signals were so regular they briefly considered whether they might be artificial, messages from alien civilizations. Instead, they had discovered nature's most precise timekeepers, stellar remnants spinning with a regularity that defies imagination. Fact number 40. Variable stars, stars whose brightness changes over time, serve as crucial tools for measuring distances across the galaxy. Cepheid variables in particular have a relationship between their pulsation period and their intrinsic brightness that makes them stellar yardsticks. These pulsating stars are like cosmic heartbeats, their regular rhythm helping astronomers map the three-dimensional structure of the galaxy. Each pulse carries information about distance, age, and composition, a stellar Morse code written in light.
The dark and hidden realms, mysteries between the stars. Between the stars of our galaxy lies not empty space, but a rich, complex medium filled with gas, dust, magnetic fields, and mysterious dark matter. These seemingly empty regions hold secrets that are only now beginning to be understood. Fact number 41. Interstellar space is not empty, but filled with an extremely thin gas, mostly hydrogen, with a density of about 1 atom per cubic centimeter. This is a better vacuum than we can create in Earth-based laboratories, yet across the vast distances of the galaxy, this thin medium adds up to enormous quantities of material. Picture the space between stars as an incredibly thin fog, so thin you could pass through it without noticing, yet vast enough that it contains billions of times more matter than all the stars combined. This interstellar medium is the galaxy's raw material, the stuff from which new stars are born. Fact number 42. Dark nebulae, clouds of dust and gas so dense they block the light from stars behind them, create some of the most striking features in the night sky. The famous Horsehead Nebula and Coalsack are examples of these dark silhouettes against the stellar background. These dark clouds might seem like voids, but they're actually some of the most active regions in the galaxy, stellar nurseries where the next generation of stars and planets are taking shape. The darkness is not absence, but potential, like fertile soil in a cosmic garden. Fact number 43. The galaxy is filled with invisible rivers of high-energy particles called cosmic rays. These particles, mostly protons and atomic nuclei, travel at nearly the speed of light and bombard Earth constantly. Some originated from supernova explosions that occurred millions of years ago. These cosmic messengers carry information about the most violent events in the galaxy. Every second, billions of these particles pass through your body, ghostly remnants of stellar explosions, accelerated to incredible energies by the galaxy's magnetic fields. Fact number 44. Dark matter makes up about 85% of all matter in the galaxy, yet we can't see it directly. We know it exists because of its gravitational effects on visible matter. Stars at the galaxy's edge orbit faster than they should if only visible matter were present. This invisible scaffolding holds our galaxy together, providing the gravitational foundation upon which the visible galaxy is built. It's like discovering that the house you live in has an invisible framework you never knew existed, one that's actually more massive than everything you can see. The search for dark matter is one of the greatest mysteries in modern astronomy. Deep underground laboratories around the world are trying to detect dark matter particles directly, while space-based telescopes look for indirect signs of dark matter interactions. Imagine trying to study something that doesn't emit, absorb, or reflect light, something you can only detect through its gravitational influence. It's like trying to understand an invisible person by watching how objects move around them. Interstellar dust grains are tiny, smaller than the particles in cigarette smoke, but they play an enormous role in galactic evolution. These microscopic specks absorb and scatter starlight, regulate the temperature of gas clouds, and provide surfaces where simple molecules can form. Each dust grain is a world unto itself, a tiny factory where the chemistry of space unfolds. On their surfaces, hydrogen atoms combine to form the universe's most common molecule, H2, which becomes the fuel for future star formation. The galaxy contains vast regions of hot, ionized gas with temperatures of millions of degrees. This galactic halo gas was heated by shock waves from supernovae and stellar winds, creating a tenuous atmosphere around our galaxy. This hot halo is like the galaxy's fever, evidence of the violent processes that have shaped our cosmic home over billions of years. It's invisible to our eyes, but glows in X-ray light, creating a ghostly aureole around the Milky Way. Fact number 48. Molecular clouds, dense concentrations of gas and dust, where temperatures drop to just a few degrees above absolute zero, are the coldest places in the galaxy. In these frigid environments, over 200 different types of molecules have been detected, including complex organic compounds. These molecular clouds are cosmic deep freezers, preserving the chemistry of space in almost a perfect vacuum. Some of the molecules found there, including amino acids and other organic compounds, are the building blocks of life itself. The galaxy's magnetic field is incredibly weak by everyday standards, about 100,000 times weaker than a refrigerator magnet, but it extends across vast distances and plays a crucial role in regulating star formation and guiding cosmic rays. These magnetic fields are like invisible highways threading through the galaxy, channels that guide the flow of matter and energy across cosmic distances. They're the galaxy's nervous system, carrying information and influence from one region to another. Astronomers have discovered hypervelocity stars, stars moving so fast they can escape the galaxy entirely. These stellar exiles were likely ejected by close encounters with the supermassive black hole at the galaxy's center or by interactions in dense stellar clusters. Picture these wayward stars as cosmic wanderers, cast out from their galactic home to drift forever through intergalactic space. They carry with them the chemical signature of the Milky Way, perhaps seeding distant regions of the universe with the elements necessary for life.
The Timekeepers, the galaxy's history written in light. The Milky Way is not just a collection of stars and gas, it's a historical archive, with each stellar population telling the story of different epochs in our galaxy's 13 billion-year history. Let's explore how astronomers read this cosmic chronicle. Fact number 51. The oldest stars in our galaxy formed when the universe was less than 1 billion years old. These ancient suns, found primarily in globular clusters and the galactic halo, contain almost no elements heavier than hydrogen and helium. They were born in a chemically pristine cosmos. These stellar elders are living fossils, their light carrying information from the galaxy's infancy. By studying their composition and properties, we can peer back through time to see what conditions were like when our galaxy was young and the universe was a very different place. Fact number 52. The galaxy's disk shows clear evidence of chemical evolution over time. Stars that formed billions of years ago contain fewer heavy elements than younger stars,
revealing how generations of stellar death and rebirth gradually enriched the galaxy with the elements necessary for rocky planets and life. This chemical evolution is written in the very atoms of the stars. Each stellar spectrum is like a cosmic birth certificate, revealing when that star was born and what the galaxy was like at the time of its formation. Fact number 53. Globular clusters, spherical collections of hundreds of thousands of ancient stars, serve as fossil records of the early galaxy. These stellar cities formed when the Milky Way was young and have remained largely unchanged for over 10 billion years. Imagine these globular clusters as cosmic time capsules, preserving samples of the primordial galaxy like insects in amber. Each cluster is a window into the distant past, showing us what stellar populations looked like in the galaxy's youth. Fact number 54. The galaxy has survived several major mergers with smaller galaxies throughout its history. Evidence of these cosmic collisions can be found in the motions and distributions of stars, particularly in the outer regions of the galaxy. These galactic mergers were not violent crashes, but slow-motion dances lasting hundreds of millions of years. When galaxies merge, their stars rarely collide. Instead, they settle into new orbital patterns, like leaves swirling together in a cosmic wind. Fact number 55. The Sagittarius dwarf galaxy is currently being torn apart by the Milky Way's gravity, creating streams of stars that wrap around our galaxy like ribbons. This ongoing merger will continue for billions of years as the smaller galaxy is completely absorbed. We're witnessing galactic cannibalism in real time, our galaxy slowly digesting a smaller companion. The Sagittarius streams are scars in the sky, evidence of this cosmic consumption, visible to those who know how to look. The origins of wonder. Long before telescopes, before modern science, before even the first written words, there were people who looked at the night sky with awe. Imagine the first humans, tens of thousands of years ago, standing by the flickering firelight. Their world was dark, and above them stretched the sky, clear and infinite. No city lights to hide the stars, no pollution to dim their glow. To them, the Milky Way must have looked like a celestial highway, a trail carved through the heavens. They gave it names, they wove it into stories. They believed it was a bridge for souls, a path of gods, or a river of light carrying mysteries too vast to explain. And here lies our first fact. The Milky Way has been seen by humans for at least 100,000 years, long before written history began. It has always been there, waiting for our eyes to lift toward it. The first stories. In ancient Greece, there was a story of Hera, queen of the gods. According to myth, when milk spilled from her breast, it formed a glowing band across the sky, the Milky Way. That's where the name comes from, Galaxias Kyklos in Greek, meaning milky circle. This brings us to our second fact. The name Milky Way comes from the ancient Greek words for milky circle, inspired by a myth about the goddess Hera. But the Greeks were not alone. In Finland, people saw it as the pathway of birds, a guide for migrating birds flying across the seasons. In China, it was the Silvery River, a celestial stream that separated two star-crossed lovers, the weaver girl and the cowherd, who could only meet once a year when magpies formed a bridge across the stars. Here lies our third fact. Across cultures, the Milky Way has been seen as a river, a road, or a bridge, each culture adding its own story to its glow. The world's oldest compass. Long before compasses or maps, people used the Milky Way as a guide. When traveling across deserts or sailing across seas, people looked to the stars and the river of the Milky Way to find direction. Fact number 4. For ancient travelers, the Milky Way served as a natural compass, pointing the way across land and sea. Imagine you are a sailor, lost on an open ocean, the waves dark and endless. Above you, the Milky Way stretches like a glowing thread. You follow its arc across the heavens, and suddenly, the world feels less empty. The galaxy itself is guiding you. The first scientists of the sky. The philosopher Aristotle once looked at the Milky Way and thought it was made of fiery exhalations from stars in the upper atmosphere. He was wrong, of course, but it shows how even the greatest minds tried to understand its mystery. Fact number 5. Aristotle believed the Milky Way was an atmospheric phenomenon, not a collection of distant stars. Later, in the year 964, a Persian astronomer named Al-Sufi described the Milky Way in his book of fixed stars. He wrote of its nebulous nature, suggesting it was not a cloud, but something made of countless stars. Fact number 6. In 964 CE, Al-Sufi described the Milky Way as a cluster of countless tiny stars, the first recorded hint of its true nature. But beyond myths, beyond science, the Milky Way has always carried something else, a sense of silence, a reminder of how small we are. Imagine standing on an ancient plain, the stars so bright that they cast shadows on the ground. Imagine lying in the grass, staring upward, realizing that you are looking not at a cloud, but at billions of suns, each one a burning world. Fact number 7. The Milky Way is made up of about 400 billion stars, each one shining like our own sun. To the naked eye, those billions of stars blur together into a glowing band, too distant for us to see individually. And yet, hidden in that blur are suns, planets, nebulae, and mysteries we have only begun to discover. The first realization. In 1609, Galileo Galilei pointed his telescope toward the Milky Way. What he saw changed everything. Instead of a smooth, glowing band, he saw countless individual stars, packed so tightly together that they seemed to merge into one. Fact number 8. Galileo was the first to use a telescope to see that the Milky Way was made of countless individual stars. This discovery was like pulling back a curtain. The Milky Way was no longer a mysterious cloud, it was a vast sea of suns. A galaxy of stars. Over time, astronomers came to realize that the Milky Way was not just a collection of stars. It was something much larger. It was an entire galaxy, a word that means system of stars. Fact number 9. The Milky Way is a barred spiral galaxy, a vast disk of stars about 100,000 light-years wide. Imagine that, 100,000 light-years, a distance so vast that even a beam of light, traveling at 186,000 miles per second, would take 100,000 years to cross it. Fact number 10. The Milky Way is so large that light takes 100,000 years to travel from one side to the other. And here we are, tiny, fragile human beings, living on a small planet that orbits one small star, tucked away in one of the Milky Way's spiral arms. Fact number 11. Our solar system lies in the Orion arm, about 27,000 light-years from the galactic center. We are not at the center of the galaxy. We are not even close. We live on the outskirts, in a quiet neighborhood of stars. And maybe that is fitting, for it is in the quiet places that wonder grows. The emotional truth. So, what is the Milky Way? It is a collection of stars, yes. A barred spiral galaxy, yes. But more than that, it is a mirror. A reminder of how small we are, and yet how connected we are to something infinite. The light you see when you look at the Milky Way tonight has traveled for thousands of years across impossible distances just to reach your eyes. Fact number 12. The light from the Milky Way takes thousands of years to reach us, meaning we are always looking into the past. And perhaps that is why we look at it with such longing, because in its glow we see not only the past of the universe, but the dreams of our own hearts. Ancient myths and stories of the Star River. The sky as a storybook. Long before science explained the stars, the night sky was a storybook. Its pages were endless, written in points of light. Every culture in every corner of the earth looked upward and created tales to explain the Milky Way's silver glow. The galaxy was never just stars. It was always something more. A path, a river, a wound in the heavens. A reminder that above us lies a mystery too vast for words. Tonight, we walk through those stories. The Greek tale of milk and divinity. The name Milky Way itself comes from a Greek legend. Hera, queen of the gods, was said to have spilled her milk across the heavens. Some versions say she refused to nurse the infant Hercules, and when she pulled him away, milk sprayed across the sky, leaving behind the glowing band. Fact number 13. The word galaxy comes from the Greek galaxias, meaning milky, inspired by the myth of Hera's spilled milk. The Greeks saw the Milky Way as both divine and messy, a reminder that even the gods made mistakes that painted the universe itself. The Roman Bridge of Souls. The Romans inherited much from the Greeks, but they also had their own vision. For them, the Milky Way was the road of the gods, a shining highway across the night sky. They believed the gods themselves used this road to travel swiftly across the heavens. Fact number 14. In Roman mythology, the Milky Way was a divine road, a pathway for gods and spirits across the night sky. Imagine that, a shining road that only the gods could walk. It turned the sky into a living city, its streets lit by starlight. The River of Heaven in China. Far to the east, in ancient China, the Milky Way was called the Silver River. It was not a road, but a stream, one that separated two lovers, the weaver girl and the cowherd. According to the legend, they lived on opposite sides of the heavenly river, forbidden to meet. But once a year, on the 7th day of the 7th lunar month, magpies flew up into the sky and formed a bridge so the lovers could cross the Silver River and reunite. Fact number 15. In Chinese mythology, the Milky Way is the silver river that separates two lovers, who meet once a year when magpies form a celestial bridge. Even today, this story is celebrated in the Qixi festival, sometimes called the Chinese Valentine's Day. A reminder that the stars, too, tell stories of longing.
The Road of Souls in the Americas. In many Native American traditions, the Milky Way was not milk, nor a river, but a path for souls. The Lakota people of North America saw it as the spirit road, where souls walked after death, traveling to the afterlife. To them, the Milky Way was not distant, it was sacred, the final journey every human must make. Fact 16. For the Lakota and many other Native American tribes, the Milky Way was the spirit road, guiding souls after death. The Maya in Central America imagined the Milky Way as a great celestial crocodile or world tree. It was both frightening and life-giving, stretching from the underworld to the heavens. The Australian sky river of emus. Across the southern hemisphere, in the lands of Australia, the Aboriginal peoples also told stories of the Milky Way. For them, it was not a river of stars, but the outline of an emu, the great flightless bird, seen not in the stars themselves, but in the dark spaces between them. Fact 17. Australian Aboriginal cultures see the Milky Way as the emu in the sky, shaped from the dark dust lanes, not the stars. It is a reminder that sometimes meaning is not found in the light, but in the shadows between. The Norse River of Sparks. In the cold north, the Norse people imagined the Milky Way as a road of sparks from the mighty hammer of Thor. Some legends say it was Bifrost, the rainbow bridge connecting Earth to Asgard, faintly glowing at night. Fact 18. In Norse mythology, the Milky Way was sometimes linked to Bifrost, the bridge between the human world and the realm of the gods. For the Norse, the sky was always a battleground, filled with gods, giants, and warriors. The Milky Way was a scar of light, proof that something divine had passed across the heavens. African stories of the Sky River. Across Africa, stories of the Milky Way flow like the river itself. In South Africa, the Khoisan people told of a girl who flung ashes from a fire into the sky, creating the glowing and of stars. To them, the Milky Way was a trail of burning embers, still glowing in the night. Fact 19. In African mythology, the Milky Way was often explained as ashes or embers thrown into the sky, lighting the heavens. The Zulu saw it as a path of animal migrations, a trail where celestial creatures walked across the heavens. The Polynesian compass. For the Polynesian navigators who sailed across the Pacific Ocean in small canoes, the Milky Way was not just a story, it was a tool. It was the backbone of the night sky, a compass that guided them from island to island across vast oceans. Fact 20. The Polynesians used the Milky Way as a navigational tool, treating it as a backbone of the sky that aligned with their sea routes. To sail by the stars was to trust the galaxy itself to guide you home. And so across cultures, across continents, the Milky Way became many things. A goddess's milk, a river of souls, a bridge of birds, a path of fire, a celestial compass, an emu in the sky. Each story different, yet each one trying to explain the same wonder. Fact 21. Almost every ancient culture had its own story about the Milky Way, reflecting how deeply it shaped human imagination. And in those stories, we see something universal. Humanity's need to find meaning in the vastness, to make the unknowable into a story we can hold close, like a fire against the cold. The emotional echo. When we read these myths today, they feel distant, like echoes from another time. But listen closely, and you'll hear something familiar. The awe, the wonder, the feeling of standing beneath the stars and asking, what is that? What does it mean? Even now, with telescopes and satellites, we still ask the same questions. We are still telling stories about the Milky Way. Only now our stories are written in equations, star charts, and cosmic theories. And maybe that is the greatest myth of all, the belief that science has replaced wonder, for in truth, it has only deepened it. In the winter of 1610, Italian astronomer Galileo Galilei
pointed a new telescope up toward the Milky Way. He wasn't the first to make telescopes, but he was one of the first to really use them to peer into the heart of the night sky. And what he saw would forever change our understanding of things. With his telescope, Galileo realized that the Milky Way was not a collection of stars, that the Milky Way was a collection of stars not visible to the naked eye, blurring together into a faint glow. It was like looking closely at sand on the beach. From a distance, it looks like a solid mass, but as you get closer, you see that it's made of individual grains of sand. Fact 23. Galileo was the first to resolve the Milky Way into individual stars, demonstrating that it was made up of countless distant ones. This was an astonishing revelation. It changed the entire way people thought about the night sky. It wasn't just a glowing mist or river. It was an enormous collection of stars, creating in a distance a soft glow in the sky.
The telescope revolution. The glass that changed the sky. The story begins with glass. Simple, fragile, human-made glass. In the early 1600s, craftsmen in Europe began experimenting with curved pieces of glass, lenses that could bend light. These were first used for spectacles, magnifying glasses, tools to help the elderly see again. But then someone wondered, what if we point this glass at the sky? That question changed everything. Fact 31. The telescope was invented in the early 1600s, transforming astronomy by magnifying the heavens. Galileo Galilei, an Italian mathematician with restless curiosity, built one of the first telescopes powerful enough to look at the Milky Way. When he aimed it upward in 1609, he discovered that what looked like a smooth band of light was in fact countless stars. We spoke of this moment before, but let us pause here again. Imagine being Galileo, seeing the Milky Way not as mist, but as a swarm of suns. Imagine the silence that must have filled him as the universe cracked open. The birth of a new sky. Galileo's discovery was just the beginning. As telescopes improved, astronomers across Europe began to map the heavens in detail. They counted stars, traced their positions, and drew maps of the Milky Way. They noticed clusters of stars, tight families huddled together, floating like jewels in the night. Fact 32. Star clusters, such as the Pleiades, were revealed in detail by early telescopes, showing the Milky Way's hidden structure. And yet, even as they mapped, questions grew. Was the Milky Way the entire universe, or just part of something larger? The nebulous mystery. Through their telescopes, astronomers noticed fuzzy patches, objects that were not sharp stars, but cloudy smudges. They called them nebulae, meaning clouds. Some were star clusters, but others, no one knew. Fact 33. Early telescopes revealed nebulae within the Milky Way, some of which were later discovered to be other galaxies. This was perhaps the greatest mystery of the time. Were these clouds part of the Milky Way or something beyond? The telescope, in giving answers, had also deepened the questions. Edmund Halley and the catalogues of the sky. In the late 1600s, Halley, yes, the same Halley whose name graces the famous comet, began cataloging stars in the southern hemisphere. His observations added to humanity's first real maps of the Milky Way, filling in gaps left by northern astronomers. Fact 34. Edmund Halley created one of the first star catalogues of the southern sky, expanding knowledge of the Milky Way's full span. The galaxy was slowly becoming charted, like a great wilderness being mapped river by river. William Herschel and the shape of the galaxy. In the 18th century, William Herschel, a musician turned astronomer, set out to count the stars. With the largest telescopes of his age,
he made surveys of the Milky Way, measuring the density of stars in different directions. From this, he drew a rough shape of the galaxy, a flattened disk with the Sun near the center. Fact 35. In the late 1700s, William Herschel attempted the first map of the Milky Way, imagining it as a disc-shaped system of stars. Though his map was not entirely correct, it was revolutionary. For the first time, the Milky Way was not just a band of light. It was a structure, a system, a home. The telescope and the dust. But telescopes did not just reveal stars, they revealed shadows. Astronomers saw the dark lanes within the Milky Way more clearly, and many wondered if they were gaps, empty spaces in the galaxy. Only much later would it be understood. These were not empty holes, but dense clouds of dust and gas, hiding the stars behind them. Fact 36. The dark rifts in the Milky Way are dense clouds of interstellar dust that block the light of stars beyond. It was as if the galaxy itself kept secrets, refusing to reveal all of its treasures at once. The wonder of double stars. Through telescopes, astronomers also discovered something unexpected. Many stars came in pairs. What looked like a single point of light was often two stars, orbiting one another in a cosmic dance. Fact 37. Many stars in the Milky Way are not alone, but exist in binary or multiple star systems. This was another revelation. Our sun seemed solitary, but most stars had partners. The galaxy was filled with relationships, with pairs locked in gravity's embrace. The telescope as philosopher. With each improvement in glass and lens, the Milky Way became less myth and more mystery, less poetry and more science, but in truth, both. For as the telescopes grew stronger, astronomers felt not only knowledge, but humility. The more they saw, the more they realized they had not yet seen enough. And with each revelation, the question grew louder. Is the Milky Way the whole universe, or just one island in an endless sea? The emotional reflection. Think of it. For thousands of years, the Milky Way was a myth. For centuries, it was a mystery. But now, with glass and lens, it became something else, a puzzle. The telescope was not just a tool, it was a key. And each time it turned, it opened a new door. Behind those doors were more stars, more clusters, more nebulae. The Milky Way, once a soft glow in the night, had become a labyrinth of wonders. And still, the story was only beginning.
The birth of modern astronomy. The century of questions. The 1800s were a century of hunger. Hunger for knowledge, hunger for order, hunger for the universe to make sense. The Industrial Revolution had filled cities with factories, railways, and smoke. But above the smog, the Milky Way still shone, silent and eternal. Astronomers pointed increasingly powerful telescopes at the stars, and though their instruments were still bound by Earth's atmosphere, their imaginations roamed further than ever. Fact 39. The 19th century saw the rise of astrophysics, where astronomers studied not just where stars were, but what they were made of. The Milky Way was no longer just a pattern in the night sky. It became a laboratory, a place where human curiosity burned as brightly as the stars themselves. Spectroscopy, reading the light. In the mid-1800s, a new technique emerged that would forever change astronomy: spectroscopy. By passing starlight through a prism, astronomers discovered dark lines across the rainbow of colors. These were fingerprints, the marks of chemical elements. Fact 40.
Spectroscopy revealed that stars, including those of the Milky Way, are made of the same elements found on Earth: hydrogen, helium, carbon, oxygen, and more. This discovery was breathtaking. The heavens were not alien, they were kin. The Milky Way was not another world, it was our world, stretched across unimaginable distances. The question of distance. But still a pressing question haunted astronomers. How far away are the stars? The Milky Way shimmered with depth, but without knowing distances, it was impossible to know its true shape. In the early 1800s, astronomers developed a technique called parallax, measuring the tiny shift in a star's position as Earth moved around the Sun. Fact 41. In 1838, Friedrich Bessel made the first successful parallax measurement, proving that stars in the Milky Way were unimaginably far away. That single measurement shattered the limits of human imagination. The Milky Way was not just wide, it was deep. Its stars were not painted on a dome, they floated in a vast ocean. The spiral nebulae mystery. While peering deeper into the Milky Way, astronomers cataloged hundreds of nebulae, cloudy patches of light. Some, like the Orion Nebula, were clearly within our galaxy, but others looked different, spiral-shaped, like whirlpools in the sky. Fact 42. Spiral nebulae were discovered in the 19th century, but no one knew whether they were inside the Milky Way or island universes of their own. This question would remain unsolved until the 20th century, but it haunted every astronomer who looked into the telescope. Was the Milky Way the entire universe, or just one island among countless galaxies? The discovery of variable stars. In 1784, long before the debate was resolved, an English astronomer named John Goodricke noticed a star that varied in brightness over time. By the 19th century, whole classes of variable stars were known, flickering like cosmic lanterns. Some of these stars, called Cepheid variables, brightened and dimmed with incredible regularity. Their true significance had not yet been understood, but soon they would become the yardsticks of the universe. Fact 40. Cepheid variable stars in the Milky Way later provided astronomers with a reliable way to measure cosmic distances. Like a lighthouse on a stormy sea, they would one day guide us beyond the Milky Way's borders. The Milky Way's dusty veil. As telescopes grew sharper, astronomers puzzled more and more over the dark patches in the Milky Way. Some believed these were gaps where no stars existed. Others suspected something more mysterious. By the late 1800s, it was becoming clear. These were clouds of gas and dust, thick enough to block the light of stars behind them. Fact 44. Interstellar dust clouds obscure parts of the Milky Way, making it difficult to see its true size and structure from Earth. The galaxy was not just a collection of stars, it was also a place of shadows, a realm where light and darkness wove together in hidden patterns. The rise of women in astronomy. In the late 19th and early 20th centuries, women began to enter astronomy in greater numbers, though often in overlooked roles. At Harvard College Observatory, a group of women known as the Harvard Computers cataloged stars by the tens of thousands, carefully analyzing photographs of the Milky Way's crowded fields. Among them was Henrietta Swan Leavitt, who discovered the crucial relationship between a Cepheid variable star's brightness and its period of pulsation. Fact 45. Henrietta Leavitt's discovery of the Cepheid variable period luminosity relationship allowed astronomers to measure distances across the Milky Way and beyond. Her quiet work would one day prove the key to unlocking the true size of the universe. Philosophy in the stars. The 19th century was not only about data, it was also about wonder. Philosophers and poets gazed at the Milky Way and saw not just science, but metaphor. The galaxy was painted into literature as a bridge between heaven and earth, a reminder of eternity in a world moving faster than ever before. Fact 46. Throughout the 19th century, the Milky Way continued to inspire poets, artists, and philosophers as much as scientists. It was a reminder that science does not take away beauty, it deepens it. The galaxy, once a river of milk, had become a sea of stars, and yet the poetry of it had not been lost. It had only grown richer. The threshold of a new era. By the dawn of the 20th century, humanity had learned much. The Milky Way was vast, made of countless stars, woven with dust and gas, and alive with mysteries. But one question loomed above all others. Was the Milky Way the entire universe, or only one island in a greater ocean? The answer would come soon. But for now, the 19th century closed on a note of wonder, humility, and anticipation. Fact 47. By 1900, the structure of the Milky Way was still unknown. Humanity stood at the edge of discovery with the greatest revelation yet to come.